Let's have a look at a more complex question now. So, the circle C has equation x plus 3 squared plus y minus 7 squared equals 29. The point A lies on the circle and has y coordinate of 9. Given that the tangent to C at A has a negative gradient, find the equation of the tangent to A. There's a lot of information in this question, so we're going to break it down, and as you've probably guessed by now, we're going to sketch it. So let's get as much information as we can on our sketch. So first of all, centre of the circle. This circle has centre at -3, 7. Let's position that about there. Now, before I just draw the circle on, I should just think, will it cross the axes? I can consider that by thinking, well, I know it's 3 away from the y-axis, and it has a radius of 29, square rooted. The square root of 29 is bigger than 3, so it will cross it. We don't care where it will cross at the moment, maybe we will later on in the question, but for the moment it will cross. Will it cross the x-axis? No, because it's 7 away from that. 7 squared is 49, bigger than 29. So let's try and get something resembling a circle. That's close enough. Okay, so we've got our circle drawn. Now we can move on to the next part of the question. The point A lies on the circle and has y coordinate of 9. Okay, so if we draw on y equals 9, we can see there are actually 2 possible locations for A. Let's read on, perhaps it will tell us more about which one of those to choose or how we can decide. Given that the tangent to C at A has a negative gradient, if we were to draw a gradient there, it would have a positive gradient. Sorry, a tangent there would have a positive gradient. If we draw a tangent here, however, it does indeed have the negative gradient which we require. So that must be where our A is positioned. Some x value and 9. Okay, excellent. Now we kind of have a feel for what this question's asking us. They want us to find an equation for that line. Okay, how are we going to do that? Well, to find the equation of a straight line, we need a point and a gradient. Currently, we have neither. So let's set about trying to find a point first, because once we've got a point, we could probably figure out a gradient somehow. So, we know the equation of this circle was x plus 3 squared plus y minus 7 squared was 29. Let's just draw that radius on. Maybe we'll need it later. Always worth drawing a radius to a sensible point, a useful point. Okay, so we know that that is 29. And we know that the point A is on our circle, so it must satisfy this equation. Therefore, we can substitute our value of 9 in. Excellent. 9 minus 7 squared is 4. So we're going to have x plus 3 squared plus 4 equals 29. We're not going to need to expand this. Remember, we know how to solve from completed the square form, and this is completed the square form. So we can just subtract the 4, square root both sides. Remember, whenever you take the square root, it could be plus or minus. We don't know, so we must consider both. X is equal to minus 3 plus or minus 5. How do we know whether it was plus or minus 5? Well, we know that A must be over here. The minus 5 would correspond to a value this side, with the tangent having a positive gradient. We know that we want to be on this side, so we must have added to the minus 3 that we started at. So x is minus 3 plus 5. We can put that in up here. X will be minus 3 plus 5 is 2. We've got our coordinate. This is excellent. Now that we know the coordinate of A, we can set about actually finding the equation of this tangent. Well, what other information do we need? We've got a point. Now we need to know its gradient. Well, we haven't been told a gradient of this line. There must be another way to figure it out. What we do know, however, is that a radius is at right angles to a tangent. Okay? Coincidentally, it's also at right angles to a chord, as long as the radius bisects that chord. So, radius perpendicular to the tangent, you'll use that fact a lot. So, if we can figure out the gradient of the radius, we should know the gradient of the tangent. That's good though, because we know 2 points which lie on this radius, so we can just do change in y, 9 minus 7 is 2, sorry. Change in x, 2 minus 3 is 5. So that is our gradient of the radius. Let's label that gradient of r. We want the gradient of the tangent, which is perpendicular to that. So the gradient of this tangent will be the negative reciprocal. Remembering that from a few weeks ago. Negative reciprocal, 5 over 2. We're away. Now we just need to choose a point, which is on our circle, and in fact where our tangent is, so we must choose point A. We cannot choose the centre of the circle. That is not part of the tangent. Y minus 9 is the same as x over x minus 2 is the same as minus 5 over 2. Cross multiplying, we get 2y minus 18 is minus 5x plus 10. Bring everything over to this side, so we're going to get 2y plus 5x minus 28 equals 0. We have the equation of the tangent. We've answered the original question. Okay. Main points on this question were, when you're given lots of information, like we were at the start, sketch it so that you understand exactly what you're being asked. And then if you're given a point on the circle and you know at least one of the coordinates, you can always find the other. Remember, we didn't need to expand. We could solve using completed the square. Be sensible about whether you choose the plus or the minus, but make sure you remember them both. And then the gradient of a tangent is the negative reciprocal of the radius to that same point. Radius and tangent are perpendicular to each other. Quick recap of coordinate geometry, and we have the question answered.